Factoring plays an important role in Chapter 2 in Math 1314. So the first thing we want to talk about is these X-intercepts. And these X-intercepts are these points right here on the graph. And notice that the Y value is 0. Okay, so these X-intercepts also have other names. We also call these zeros, factors, or solutions. So anytime they ask you for the zeros, the roots, solutions, or the X-intercepts, then these are the points that they're referring to. So the zeros here in this graph are at x equals -2 and x equals 3. So if we set x equals -2 and x equals 3 to 0, then we get the following. If I bring the -2 to the left, then I would end up with x plus 2 equals 0. And if I bring the 3 to the right, to the left, then I get x minus 3 is equal to 0. These are called factors. Okay, so if we have two factors and we want to multiply together, then we would get x plus 2 times x minus 3. Then we can multiply x times x, which is x squared. X times -3 is -3x. 2 times x is 2x. And 2 times -3 is -6. Then you want to combine your like terms. -3x plus 2x is a -x minus 6x. So this would be our answer. So let's try another one. So here we're going to multiply 2x times x is 2x squared. 2x times 4 is 8x. -2 times x is -2x. -2 times 4 is -8. Gather our like terms. 2x squared, 8x minus 2x is 6x minus 8. So our goal in factoring is to take a polynomial that looks like this and find its factors. Once we know the factors, then we can find for those zeros. So when we're looking at factoring, there's this row map that you want to factor. The first thing is for us to see if we have a GCF, and GCF just stands for the greatest common factor. If you have a GCF, then we also want to factor that out, but then we want to see, do we have 2 terms, 3 terms, or 4 terms? If we have 2 terms, then we can do difference of squares. If we have 3 terms, then we'll do this method or this method. And the difference between them is that this one has a number in front of the x squared. And if we have 4 terms, then we'll do grouping. So first we'll talk about the greatest common factor. And so the factors of 18 are just the numbers that you can multiply together to give you 18. So for example, 1 times 18 gives me 18. 2 times 9 gives me 18. 3 times 6 gives me 18. And so we say that these are all the factors of 18. So if you had two numbers, let's say I had the number 24, the factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So these are the factors of 24. So the ones that are common to both are 1, 2, 3, 6. But here, 6 is the greatest common factor. Okay, so that's what we're going to be interested in. So besides the numbers, we also have to worry about whenever we have variables. So for the x squared, we would get x times x. For x cubed, we get x times x times x. And for x, we get x. And so notice here that they only have one x in common. And so that would be part of your greatest common factor. And that's going to be the case that the lowest exponent is always going to be the common factor for your variables. Okay, so let's try an example here. So the first thing you want to worry about is the numbers. We have a 6, a 4, and a 10. So the factors of 6 are 1, 2, 3, and 6. The factors of 4 are 1, 2, and 4. The factors of 10 are 1, 2, 5, and 10. And so if you notice, they have 1 in common and they have 2 in common. But the greatest one is going to be the number 2. And then we also have variables x cubed, x squared, and we have an x. So x is going to be your greatest common factor for the variables. And so together, our greatest common factor is going to be the number 2 and the letter x, which is the variable x. And so what you want to do is we're going to have our greatest common factor here. And so for our polynomial, what you want to do is you can divide by the greatest common factor. And so 6 divided by 2 is 3, and x cubed divided by x is x squared. 4 divided by 2 is 2, and x squared divided by x is x. And then we have 10 divided by 2 is 5, and x divided by x is just going to be 1. So I can factor this polynomial as 2x parentheses 3x squared plus 2x plus 5. So let's try the next one. We have 21, 18, and 27. So 1 times 21, 3 times 7 are the factors. And then for 18, we have 1, 2, 3, 6, 9, and 18. And 27, we have 1, 3, 9, and 27. So we can see here that the greatest common factor is 3. And they each have at least one x. So we have x to the fourth, x cubed, and x squared. The smallest exponent, in this case 2, will be part of our greatest common factor. So our greatest common factor would be 3x squared. And so if I write my 3x squared on the outside, and I divide my polynomial by my GCF, then we get 21 divided by 3 is 7. X to the fourth divided by x squared is x squared. 18 divided by 3 is 6. X cubed divided by x squared is x. 27 divided by 3 is 9. X squared divided by x squared is 1. So we end up with this here. Example 7, we have 4, 2, 1. And if you notice here, my greatest common factor is going to be 1. So if I factor out a 1 from this, I'm going to get itself. And then notice that they don't all have an x. This one's missing an x. And they don't all have a y. So we cannot factor out our greatest common factor. So there is no GCF. So we look at other methods. And the next method would be this factor by grouping. Okay, so let's look at factor by grouping. So in factor by grouping, notice that you're going to use this method whenever we have 4 terms. So whenever you're going to factor by grouping, the first things that we should look for is we're going to group terms with common factors. We're going to factor out any greatest common factor that we see from the group terms. And then we can check our work by multiplying our 2 factors together. So basically what you want to do is we're going to group the first 2 as group 1. And then we're going to group the second 2 as group 2. And so if we look at group 1, we have 8 and 4. So the greatest common factor for 8 and 4 is 4. And then the 4 has an x squared, but the 8 doesn't. So the only thing that I can factor out of the group 1 would be a 4. So if I divide 8 divided by 4, I get a 2. And 4 divided by 4 is going to be a 1. Okay, so my greatest common factor was a 4, so I divided this by 4. and I divided this by 4, and I ended up with this. Now, the idea when you're grouping by factoring by grouping, whatever we get in this parentheses, we want to get the same thing in the second parentheses. And so I'm just going to write it out because that's what I hope to get once I factor this. So if we look at this, x cubed y minus 2xy, what they have in common here is 1y because they both have 1y. And then you have x cubed and x. And so I'm going to factor out an xy. So if you notice now, xy times 2 would give me a 2xy, but I need the 2xy to be negative. So I'm going to put a negative here. So negative xy times 2 gives me a negative 2xy. Negative times a negative is a positive, and x times x squared is an x cubed, and we get x cubed y. So now notice that they have these two things in common. So I can factor out what they have in common, which is 2 minus x squared. And if I factor out a 2 minus x squared, I'm left with this 4 here. And if I factor this 2 minus x squared, I'm left with a negative xy. And so this would be my polynomial in factored form. And then to check your answer, we can just multiply the two factors. So 2 times 4 is 8. 2 times negative xy is negative 2xy. Negative x squared times 4 is negative 4x squared. Negative times negative is a positive x cubed y. And so if you notice, this is what we started with. Okay, let's try a couple of more examples. So I'm going to group this term here. And I'm going to group these guys here. So if we look at the first one, the numbers here are x cubed has a 1 and x squared has a 5. So the greatest common factor of 1 and 5 is just going to be 1. So we don't need to worry about factoring out any numbers, but they both have an x cubed in common. Or they have an x cubed and an x squared, so they both going to have an x squared in common. So if I divide this by x squared, x cubed divided by x squared is x. And if I divide this by x squared, then I'm left with 5. And then if we look at this here, we have a 2 and a 10. So what they have in common is going to be 2. And the 10 doesn't have an x, so we don't have to worry about that. So if I factor out of 2 from 2x, 2 divided by 2 is x, and 10 divided by 2 is 5. But remember what I mentioned earlier, whatever we have in here, we want it to be the same. So I'm going to write x plus 5. I know they have a 2 in common, so I'm going to put my 2 in the front. But notice that my 2x here is negative. So notice that my 2x has a negative in front. So I'm going to have a negative here. So I'm going to end up with negative 2 times x is negative 2x. Negative 2 times 5 is negative 10. So now I can see they have this in common. So I'm going to factor out an x plus 5. And if I factor out an x plus 5, then I'm left with an x squared. And if I get this x plus 5 out, I'm left with the minus 2. So our polynomial x cubed plus 5x squared minus 2x minus 10 is equal to our factored form x plus 5 times x squared minus 2. So if you were to multiply this out, then you will end up with this on the left side. And so I'll let you check your answer. X plus 5 times x squared minus 2 will be equal to x cubed plus 5x squared minus 2x minus 10. Okay, let's try the next one. So here, 3x cubed minus 2x squared, what they have in common is x squared. They both have a variable of x, And so the question is, how many x's do they have in common? And remember that it's the lowest exponent, so they're going to have an x squared in common. The 3 and the 2, the only thing they have in common is a 1. And so if I divide 3x cubed by x squared, I'm going to be left with 3x. So x squared times 3x gives me a 3x cubed minus a 2. And then on this side, our trick here is that we want to have the same thing. So if we look at 4 and 6, what they have in common is going to be a 2. So I'm going to write my 2 in the front. And now 2 times 3x gives me a positive 6x, but I want it to be negative, so I'm going to have a negative here. So negative 2 times 3x is negative 6x. Negative 2 times negative 2 is a positive 4. And so now this is in common with this, so I can factor that out. If I take 3x minus 2 out, I'm left with an x squared. And if I take out 3x minus 2 on the right side, I'm left with a minus 2. And I will let you check your answer by multiplying 3x minus 2 times x squared minus 2, and that should result into 3x cubed minus 2x squared minus 6x plus 4. Okay, let's do one more. So if I put these together, then the first two only have an x squared in common. So that's going to give me an x plus a 2. So we want to have the same thing on this side. So we have x plus 2. And then the 9 and the 18, what they have in common, for the number 9, we have 1, 3, and 9. For 18, we have 1, 2, 3, 6, 9, and 18. So 9 is what they have in common. I need the 9x to be negative, so I'm going to have a negative here. And negative 9x is negative 9x, and negative 9 times 2 is negative 18. And so notice that they have an x plus 2 in common. So I can factor out an x plus 2, giving me with an x squared minus 9. So every time that you finish factoring, you always want to check, can I factor my factors any further? And so it just happens here, x squared minus 9 is actually going to be factored as x plus 3 times x minus 3. And we'll talk about why that happens later on in the video. Okay, so other polynomials that we'll have to factor are when they look like x squared plus bx plus c. And if the number in front of x squared is a 1, then we're going to be factoring in this form. And so basically, what you want to do is you want to take your constant here, which is a 6. And we're going to, well, before we do anything, if your constant is a negative, then when we do our factoring, you're going to have one positive and one negative. Okay. If your constant is positive, then you're going to have the same sign. So you're going to have x plus and x plus, or you can have x minus and x minus. Okay, so if the constant is positive, you'll have same signs. If your constant is negative, then you'll have one positive and one negative. So you want to remember this right here. Okay, so for example, if we have this polynomial x squared minus x minus 6, the negative 6 here is going to tell me that one of my factors is negative, one is going to be negative, and one is going to be positive. And then I'm going to have an x times an x. So x times x is x squared, And then our goal is going to figure out what goes in here. Okay, so to do that, we can look at our constant, which is 6. And we can have 1 times 6 or 2 times 3. And so since I have a negative here, then I'm looking at the difference. So if I subtract 1 minus 6, I'm going to get a 5. And then 2 minus 3, I'm going to get a 1. And so that means that since I have a 1, notice that your middle term here has a 1 here. Okay, so that this is going to be the factors that we want to use. Now you always want to put your bigger number first to assign the sign of the middle term. So here I'm going to have a 3, and then I'm going to have a 2 here. Okay, so if you notice here, if I was to multiply this out, I get x times x is x squared, x times 2 is 2x, negative 3 times x is negative 3x, and negative 3 times 2 is negative 6. And so this would give me my polynomial that I had from the beginning. Okay, so our polynomial x squared minus x minus 6 is equal to these factors x minus 3 times x plus 2. So let's try another one. So here we have x squared plus 16x plus 60. So we're going to have two parentheses. We're going to have an x and an x. Now my c is positive. That means that my signs have to be both the same. Well, since my middle term is also positive, then that means that these are both going to be positive. Okay, so I look at my middle term, which is 60. Okay, so my middle term is 60. So I can get 60 by multiplying 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. And so since I have a plus here, I'm looking at the sum. If I add these, 60 plus 1 gives me a 61. 30 plus 2 gives me 32. 20 plus 3 gives me a 23. 15 plus 4 is a 19. 5 plus 12 is 17. 6 plus 10 is 16. And notice that the number that we want is 16. That's the middle term here in the polynomial. And so 6 and 10 will give me that 16. So I would use a 6 and a 10. So this polynomial x squared plus 16x plus 60 is equal to x plus 6 times x plus 10. So what happens if there's a number in front of the x squared, a number other than 1? Then your first step is going to be to multiply that number a times c. So we say a times c. So in our example, we have 2 times 4, which is equal to 8. So we're going to take this factor, get its factors, 1 times 8, 2 times 4. Now the number that we want is a negative 7. Since I have a negative here, then I'm going to be looking at the difference of these numbers. So 1 minus 8 is 7, 2 minus 4 is 2. So since I have a 7 here and that's what I want, then we're going to look at these factors. So in this example, so remember that since this is a negative, one sign is positive and one is negative. And we want a negative 7x. So we're going to have x minus 8x. And that's going to give me that negative 7x that we're hoping to get in the middle here. So what we're going to do is rewrite this problem as 2x squared. Instead of negative 7x, I'm going to write it as x minus 8x. And then you have your minus 4. And so what you might be thinking is, well, we had 3 terms, now we have 4 terms, and that's okay because we can use factor by grouping. So in the first 2 terms here, I have x in common, so I can factor out an x, 2x plus 1. And I want this side to be a 2x plus 1. 8 and 4 have a 4 in common. and I want the 8 to be negative. So 4 times 2, negative 4 times 2 is negative 8x, and negative 4 times 1 is negative 4. So now they have a 2x plus 1 in common. So I can factor that out. If I factor it out from the first term, I'm left with x, and I factor out from the second term, I'm left with 4. Okay, so what we're saying here is that 2x squared minus 7x minus 4 is equal to 2x plus 1 times x minus 4. Okay, so again, the process here is first multiply a times c. So we multiply 2 times 4 gives me 8. And then we're hoping to get a negative 7x. Since there's a negative here, I know I'm going to take the difference. So 1 minus 8 gives me a 7. And 2 minus 4 gives me a 2. Well, I want that 7. And since I have a negative here, I'm going to have opposite signs. So I can assign the 1 an x and the 8 a negative 8 so that I can get negative 7x. Then I'm going to rewrite my polynomial into 4 terms, 2x squared. Instead of negative 7x, I wrote it as x minus 8x. And then we have minus 4. So let's try the example here. So first we multiply 6 times 20. That's going to be 120. And then since we have a positive here, that means that the signs would be the same. And since this is negative, then both signs would be negative. Okay. So the factors of 120 are a lot, right? So 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20, 8 times 14, 15, and then we get 10 times 12. Okay, so what we're looking for is the sum. So if we add 2 of these, which will give us a 23. Well, that's 121, that's 62, 43, 34, 29, 26, 18 plus 5, 8 plus 15 is going to be, so 8 plus 15 would be 23, and 10 plus 12 would be 22. We want the 23. That means these would be our factors. And so the signs have to be the same. So I'm going to have negative 8x minus 15x, and notice that gives me a negative 23x. Okay, so when we write our polynomial, we have 6x squared. Instead of negative 23x, I'm going to rewrite that as negative 8x minus 15x plus 20. Okay, so now what we can do is factor by grouping. So if you notice here, I have a 6 and an 8. So the greatest common factor of 6 and 8 is going to be a 2. And x squared and x, the greatest common factor would be an x. So 6x squared divided by 2x would give me a 3x. And 8x divided by 2x would give me a negative 4. We want this side to be the same. So I write 3x minus 4. And 15 and 20 have the greatest common factor common to both would be a 5. I need the 15 to be negative. So negative 5 times 3 would be negative 15x. Negative 5 times negative 4 will give me a positive 20. Now they have this parentheses in common. So we can factor out a 3x minus 4. If I do that, then I'm left with 2x minus 5. So my polynomial 6x squared minus 23x plus 20 is equal to 3x minus 4 times 2x minus 5. Okay, so why is factoring important? Well, we can take a problem like the one we just finished working. And so if you notice in example 12, it says to factor, but example 13 says to solve. So anytime it says to solve, we're going to be adding or setting the problem equal to 0. So if we factor, and we already factored this came out to 3x minus 4 and 2x minus 5. We can put the factors here. So the factors are 3x minus 4 and 2x minus 5. So since I have these two factors being multiplied equal to 0, then we can set each one equal to 0 and solve for x. So if I add 4 on both sides, divide by 3, then I get x is equal to 4/3. And if I add a 5 here on both sides, divide by 2, then I get x is equal to 5/2. And so really, these numbers that you just found are going to be in this number line here. Okay, so you'll have 1 point here and 1 here. So we can say this is 4/3 and 5/2. And so that's why factoring is important, because it's going to help us to find these numbers in chapter 2.